So the problem book I'm doing is problem 1. It's not in the book, it's the activity of the damped oscillators. And it is a spring with a spring constant of 1100 newtons per meter and a mass of 4 kilograms. Has a damping force of negative 56 x dot. So then I set the equation up. X double dot is equal to negative omega x minus 56 x dot, where omega x is just the square root of k over m, which comes out to be 17.7, something around there. And then I moved everything to the other side of the equation, and I substituted 56 for 2 beta, and I turned omega into omega squared. And then so I solved for the roots, and it came to negative beta plus or minus the square root of beta squared minus omega squared. And I plugged that into the solution, exponential solution for oscillators. And then I took the derivative of that and found the velocity solution. And then, so the boundary conditions were given as x is 0 is equal to a, and x dot of 0 is equal to 0. So because the exponents depend on t, the only t in the equation is the exponents, which the exponent of 0 is equal to 1. So it would turn into a is equal to c1 plus c2, and 0 is equal to negative beta plus the square root of beta squared minus omega squared c1 plus negative beta minus the square root of beta squared minus omega squared c2. And then, so then I took the velocity equation and the value in front of C2, I took this value and multiplied it across the whole position solution, which effectively just canceled out the C2s, and then I was able to subtract these equations and solve for C1. So when I subtracted them, I got that the BC1 plus the negative BC1 plus BC1, they cancel out, and you're left with negative 2 beta squared minus omega squared C1. And then, of course, you gotta go and divide that on each side. So then C1 becomes negative beta minus the square root of beta squared minus omega squared, all over negative 2 times the square root of beta squared minus omega squared times a. And then so because a is equal to c1 plus c2, I substituted this into c1 and then solved for c2. So c2 came back to be it came beta plus the square root of beta squared minus omega squared over 2 times the square root of beta squared minus omega squared plus 1a, because you can factor out the a's of both and you're left with the 1a. So then I'm not really sure why I did it this way instead of using numbers in the first place, but so then I went back and I solved for beta. So beta came out to be 28, and omega, the square root of 1100 over 4, came out to be 16.7. And then so I solved for the square root of beta squared plus omega squared, which came out to be 27.7. And then I plugged all the numbers in for a. And then so when all the numbers are plugged in, it should be negative 55.41. So it comes out to be 1.05a. And then instead of solving for the second one, once I realized I did it a bad way, I substituted 1.05a into the equation, rearranged it, and got C2 is equal to negative 0.05a. So then I substituted that back into the equation. So x of t is equal to 1.5a e to the negative 0.29t. That should be negative. Minus 0.05a e to the negative 55.7t. And then for x dot of t, I did the same thing and got that x dot of t is equal to negative 0.03a e to the 0, negative 0.29. Plus 2.785 a times a e to the negative 55.7 t. And you can see that the position and kind of the velocity mostly depend on the first part of the equation or the solution, because e to the negative 55.70 t is going to be very super small.